In this video, I want to talk about generating fake data from this kind of causal graph. So essentially, how do you generate a data set that's not a real data set, but that would look like a real data set, assuming that this graph actually encodes all the causal relationships correctly. Okay, so we'll talk about generating one data point. So in order to generate a data point, first what you do is you set those variables where there is no causal relationship between any of those variables and something above them that causes them. Okay, so how would you do it? Well, you'll probably say something like, okay, so male will kind of assume that, there's like a probability of 50% of being male. As we kind of mentioned in class, actually, males are a little bit overrepresented at birth, but whatever, it's going to be 50%. So how we're going to do it? So, well, I'll just kind of write it in R notation for now. So I'll say R binom, and I want just one sample, and I want a sample from just one. So I want the output to be 1 or 0, right? So because this is binomial, this is not Bernoulli, so I specify n equals 1 to make it Bernoulli, and then I'll say 0.5 over here. So male is going to be 0, 1. Okay. For aggression, we actually have to make a modeling assumption here, right? So we don't know in advance kind of like how aggression is distributed. We don't even know how it's measured. So what I'll do is I'll just say, well, let's make it just standard normal. So it's going to be some measure of aggression that's usually like between -2 and 2 or something like that. So I'll just do it like that. And with experience, I'll do the same thing. So that kind of means that you might have negative experience. Interpret it how you want. Like maybe actually you have experience, but it's like actively bad for your driving. Like it was like very atypical conditions or something. Okay, so we'll do R norm 1. So now that those are set, we get to the interesting part, because here we need to actually use our model. Arguably, those are parts of the model as well, of course. So how do we use the model? So we'll say, okay, so let's say that I want to generate red car. Okay, so red car, just name the variable like this. So it's a Bernoulli variable. So this part is going to be the same. And now what I need to do is I need to just compute this thing, right? So let's say that I'll define a function sigmoid. So let's, for completeness, just actually define it. So sigmoid, I'll define it as a function of z, and we'll just, return 1 divide 1 plus x, and this x is the exponent, right? X of minus z, like so. And this is going to be sigmoid. And here, like, I'll call it like A0 because that's more convenient. So I'll say A0 plus A1 times male plus A2 times aggression. Okay, and so on. So now I have red car, so now I'll also do danger. After I do danger, I get to generate the number of accidents. So just try that, and then you can just call this kind of function where you define male, aggression, experience, red car, and so on, and then you get to return it, and then you get to call this function multiple times using, for example, replicate, like we saw in class, in order to create a whole data set.